This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's episode, a lot of policy news coming out of the U.S. So the Biden administration has put a bunch of awards out. There's clean air and cleaner fuel. There's a big push for improving some of that efficiency and reducing carbon emissions, getting sustainable airline fuel developed, all these sort of things. So the Biden administration is pushing a lot of money out to the FAA and other agencies to some large aerospace companies themselves to help to develop some of these technologies. So we'll talk through a bunch of the implications there. In our engineering segment, we're going to talk about Northrop Grumman's new model of an autonomous aircraft that's got some serious speed, possibly used for future drone missions. The Boeing 737 MAX is extending wheels, which are really unique and interesting. And we'll talk a little bit about a 2 megawatt electric motor from Wright. So let's start, Alan, with the FAA. So Biden has, the administration has earmarked some money to the FAA. And as part of their CLEAN program, they're doling a lot of this out to General Electric Aviation, Honeywell, Pratt & Whitney, Boeing, Roar, Delta Tech Ops, GKN Aerospace, MDS Coding, and America's Phoenix. They're all working on different projects to meet some of these standards for CO2 emissions, hoping to reduce that by about 20%, NOx emissions by 70%, and noise as well, also particulate matter. So give me some of your perspective on this. Obviously, reducing emissions is difficult, and you've talked a bunch at length in the past about how maybe the airlines should be not quite in the same boat as, other forms of transportation.
Yeah, so the Biden administration essentially handing out checks to some larger aerospace companies is kind of unique, and they can do it under the veil of a lot of different projects at the moment. And the obvious one for them is clean air, right? So I think this is sort of indicative of a larger problem that's going on, that the airline industry in general has been in a financial hurt, and they've been asking Congress for some relief for at least a year, maybe a little bit longer now, and they're starting to get it in different forms. So there's been several $100 million, over $500 million doled out so far, and I think more is yet to come. Now, you kind of wonder if GE and Honeywell weren't already on some of these tasks, particularly GE. GE's been pushing cleaner skies for a long time, and they've been doing a lot of work internally forever. So this is not unusual for them, but I think it's just a unique way of trying to get funding to these companies. And I think the bigger scope is that at what point will the Biden administration start to realize that they need to get the airline industry going, and pumping cash into it isn't a long-term fix. It's a short-term bandage. Don't you see that, Dan? Like we got to get people flying again, and it seems like for some policy reasons we're avoiding that. And in fact, I think it was again this week where Dr. Fauci was talking about restricting people's access to travel on airlines and trains and buses and everything else if they didn't have a vaccine card, which is just makes friction, right? Friction reduces travel.
Yeah, and I mean that's true. Yeah, I guess I'm not sure how all the pieces fit together, because some of this money is going to, like you said, these aerospace companies who are developing technologies for the future. Obviously, that's good for his agenda, because it says, hey, we're active, right, trying to fight against carbon emissions, for climate change. So for that, liberal base who's, really concerned about that. And of course, there's obviously moderates and conservatives who care about the environment as well. That seems like an important part of it. Now, $100 million to those bunch of companies doesn't seem like that much money. especially considering, engineers are well paid and hard to find people. So I don't know how far that money goes on the one hand. And of course, there's a lot of different layers to this. So they're also, besides the aerospace companies, they're giving 482 million in pandemic relief to the greater, aviation industry. So some of the airliners trying to keep jobs, and trying to keep those companies from cutting jobs. And then, of course, there's all these other standards that he's implementing. They're trying to get to a greenhouse gas emissions decline of 20% by the end of the decade. So trying to get that down by 2030. Do you feel like that's a realistic goal? 20% cut seems pretty big at this point, especially considering, well, like you said, how hard aviation companies are trying to reduce fuel consumption anyway.
Right. Another 10%, I think, is going to be difficult at this point just because of the advances the industry has made over the last 30, 40 years. There's not a lot of extra room to squeeze out efficiencies. You're kind of there, right?
Feels like kind of like the Olympics. Like sprinters are so fast now, they're not going to jump from 9.7 to 9.4. Like the human capacity is getting pretty close, right? Is it kind of the same way on aircraft or not so much?
That's a really good point. Do you remember a couple of years ago the discussion and the research done about Jesse Owens and saying if you had put Jesse Owens in today's footwear and on today's athletic tracks that he'd be running just as fast as like a Usain Bolt? Like they'd be really close. He would be competitive in that arrangement, even though that was 1936 or somewhere in there when he competed. Right. So it sort of has the same feel to it. Like, yeah, we have this existing technologies. There's only so much you can squeeze out of it. So you're just basically changing the track shoes, so to speak. The core of it is still pretty much the same. There's only so many things you can do there.
Yeah, he was incredible. He like obliterated people back then. Like he was so much faster than the common man of his day. But yeah, and of course Usain Bolt is a great example because he seems like the perfect specimen of a human being to run as fast. Long levers, incredibly explosive. Like he's built to sprint as much as any human's ever been. And so like improving on Usain Bolt seems really hard, right? Like he's the fastest human in the world. It's like, how do you get better than that, right? Because training is pretty modernized. There's a lot, it seems like there's a lot of parallels between the two worlds, but are any of these fuels going to make that big of a difference? I don't know and we've talked a little bit about some of the sustainable fuels, but are they really going to be able to put the performance in the same category? And you've talked about safety, like you don't want to just like throw some new fuel through a system because in a car, if the ethanol mix or something, for example, doesn't work, the car rolls to a stop, right? But planes can't glide down to a stop, obviously.
Right. Well, I think it comes down to energy density in the fuels, right? And some of the sustainable fuels have less energy density, which means we got to carry more of them, which means overall they can become less efficient. So is it really worth the development and the extra cost for something that's less efficient, or do you just stick with what you have right now and try to make it more efficient? That's a really good question, because I think with the advent of the electric motor, at what point do we just say, all right, we've honed the Jet A fuel market as best as we're ever going to get it, or really close to it. Maybe we can squeak out another 2-3%. Let's just say that. And then whatever aircraft we can transition over to electric, we transition it to overall the whole industry is emission profile. That may be the way that it's accomplished, but I don't like the way that this is going in the sense of it's like an edict from on high, and engineers are just supposed to salute to this bureaucracy that's creating an emissions standard out of whole cloth. That doesn't feel right. And as you can see, as a result of that, the aircraft industry as a whole is really suffering and has not been able to get off its feet, and it needs to, because there's a lot of, it's almost like the automotive industry. There are a lot of jobs signed up in aviation right now.
Yeah. Yeah, and of course, the reporting from the AP News explains that only 2.4 million gallons, we talked about this in the past as well, only 2.4 million gallons of sustainable aviation fuel were consumed or were produced as of 2019. And that's in comparison to the airlines burning 21.5 billion gallons. So 2.4 million into 21.5 billion is 0.01% of the supply. So to get that up to the point where it's, significantly higher seems like a really big step in, like you said, that 9-year period, because who's going to build the infrastructure and the plants to produce that amount of fuel? And like you said, is it going to be up to par? And like you said, is it going to be more economical in the grand scheme? Because you start to think of carbon, the total carbon cost of, and that was like we've discussed, that was part of the problem with ethanol. It was like people were like, well, okay, so we're using this from corn, but we're also having to truck this and do more. Like we have to process more. There's so many more things involved where it didn't seem. And I don't know what's ultimately happened with ethanol, but it seems like it just like sort of quietly lost favor. And I know it's still used in the Midwest, but you don't see it very much. Yeah.
Right.
Yeah, and I think I feel like is really complicated because I didn't know a lot of this, and I think when you start to think of the emissions that apply, you just think that, oh, okay, well, emission standards should blanketly apply. I don't know if blanketly is a word, but I'm using it as a word. It should apply in a blanket in a blanket manner to all forms of transportation. Like, why should aircraft get a pass over trains or cars, et cetera? But to your point, being an engineer who knows the industry, very intimately, there's just a lot more context to that. Like you said, like they've been trying to reduce emissions forever because it's good for business, and that's probably the best push to any of them is like, hey, this is good for business. We want this just as much as anyone else does, and then to say, hey, well, you have to do this like the cars do. That's just like where I feel like people they miss the greater point. And like you said, the energy density thing is a really interesting, not public, the public are not privy to that. They don't understand quite that. Yeah, you might have to burn 20% more fuel to get the same output. And is that better? Yeah, it's really complicated, which I wonder if they dive into that enough, trying to explain like this is why we're doing this when they're trying to push some of this legislation, even if it's just suggested sort of targets.
Right. I think the aviation community itself sort of knows these things, but as we see it on our renewable energy podcast, when we talk about things like energy density and the overall cost of energy creation, on the aviation side, that never really gets discussed in public, which is weird. So I think we're going to get to that point, eventually going to get to that point when push comes to shove and the administration, the bureaucracy starts to push, the aviation aerospace industry is really going to push back and say, hey, look, this is not going to be a long-term solution, maybe a temporary solution, but it's not going to be a long-term solution.
Mm-hmm. Well, let's talk a little bit more about the funding that's been earmarked for aviation aircraft companies. So it's not just like commercial airliners, but for example, the largest recipient of some of this government funding is Spirit AeroSystems, which makes fuselages and other parts for Boeing. They're a big supplier, and they're in Kansas, your hometown. So they're going to get $75.5 million, which the government says will protect 3,000 plus jobs. So I mean, is that a good move, or is this, like you said, a myopic move? I mean, what do you think this is gonna? What do you think the long-term and short-term implications will be?
Yeah, there's just an announcement out today talking about this. There's about $100 million going to the state of Kansas and different aerospace affiliated companies. $75 million is going to Spirit AeroSystems, which is in Wichita. Another $15 million is going to Learjet. So there's $90 million out of the 100. The remaining 10 kind of gets dispersed around to different smaller aviation related businesses. The emphasis there is on jobs and retaining jobs. So I think there's around 4,000, 5,000 jobs. They say they're going to be able to keep employed, which is a big deal, right? 5,000 jobs essentially in Wichita, Kansas is a big deal. I guess the question is, how long is this going to go on? And how much longer can we sort of tie this over with just pouring cash into these companies? Because either Boeing's going to get up to production and Spirit's going to be making money or they're not. Learjet's in a little bit of a different mode because they've essentially shut down all aircraft production. The last Learjet, I think, comes out in the next couple of weeks, I think. So they're in a little bit of a different struggle. But all the smaller aviation companies are all relying upon the aviation industry as a whole to be flying in and modifying and upgrading and doing all the things that happen there, and it's just not happening at the rate that they need it to. So it feels like sort of an inside job a little bit. Kansas has a very strong delegation when it comes to aviation and pushing the FAA or the Commerce Department to kick out funding towards their state. If you look at the way that it's described in some of the articles, it says the Commerce Department, is the Commerce Department reached out to the companies that could be helped by this funding and made sure that they applied. So you see this sort of like this little inside chain, like, the phone's ringing. Hey, we're going to give you $50,000. Would you like it? Yeah, we're struggling. Sure, we'll take 50 grand, right? That's the kind of thing that's happened there, and that just plays into the larger frame of, hey, when are we going to get off our backsides and get life moving again? And as of yet, I haven't seen good markers on that. It seems like over the last week or so, the COVID response and the Biden administration's push to mandate vaccinations is not going to help that situation any. Particularly, most of these corporations that we're talking about in Kansas have over 100 employees. Yeah, so that's going to be a fight.
Well, and of course, on the other side of it, I mean, I know employers are really struggling to get employees at this time, right? So, we know, was it Spirit that was struggling, that had to start canceling flights? I think a couple airlines had to cancel some flights or trim back because of staffing shortages, and I think that's some of the fears behind unvaccinated employees, where they don't want to have another, like they can't afford any more losses. So I get it from that end, but you're right. Anytime you make more friction, it's going to make it more difficult for people to travel and then bottleneck to some degree. But it's hard to say how much. Yeah, I mean, and I guess we'll see what COVID holds in store for the winter. But a lot of this stuff we're just not going to know the result of until we kind of get through it. Unfortunately, probably just a lot of hindsight will be the best that we'll have. But
right, yeah, I agree.
Yeah. But I mean, are you optimistic by the amount of money that's been doled out? I mean, what's your overall? I mean, considering all these different financial awards, was this a net positive or sort of neutral, or you give it a thumbs down?
I think it's at best a neutral at this point. What you would like to see is the competitive nature of the aviation marketplace start to kick in again, where Spirit is competing with the GKN, and all those big Honeywell is competing with Collins, and you're having those big colossal battles for market share. We're not having those at the moment. We're just like everybody's just letting orders come in. Everybody's stable. We're not trying to do too much. We're not trying to expend too much effort on any particular project. And let's reduce our cash burn. Let's not do much in terms of advertising. Let's just kind of lay low for a while. And that has a similar feel to what I remember from the late 70s into parts of the 90s, into the early 2000s again, which is the aviation industry knows how to conserve cash and to try to survive. And it feels like we're in that mode right now, and they'll stay there for a while. And the flip side of this, which is not really thought about when this happens, is those aviation companies aren't really going to hire too many new engineers. And so it creates this little lull in the employment base. So you have these wide spans of engineering age groups and employee age groups in terms of line workers and that sort of thing, where they're in these discrete modes of, there's a group of people roughly the same age that were during the last upturn, and then there's a 10-year delay, and there's another group of people that are all hired at the same time. So you don't have this continuity, and I think that in itself hurts aviation more than the economy does, because it just you just have these really unique internal machinations that happen because of the span in engineering time, and things aren't handled down. I don't think things are handed down like they would be in a sort of continually growing, increasing business cycle.
All right, moving on. We got a couple things to talk about on the engineering side today. First, let's start with Northrop Grumman. They've unveiled art for their Model 401 and Model 437 aircraft, which will be autonomous. that they hope could be the Air Force's next big generation of drones, and accompany manned planes into battle. This is that sort of hybrid human and AI potential, force in the skies. That seems like it makes a lot of sense. So the Model 437 will have a 3,000 mile range, which is crazy. And is also going to be extremely fast. I think getting as high as Mach 0.85. Alan, what features strike you here? It looks a lot like any other almost supersonic jet, that sort of really stealthy design, a lot like the Predator. But what sticks out to you here as far as the engineering?
Well, I think the range does, and the ability to be stealthy, which is automatic at this point. Not even discussions about that. It just is. You can tell by the shape of the aircraft that it's going to has some stealthy features just by the shape alone. And when you take the human out of the aircraft, you also rip out a number of aircraft systems that have to be there. Flight instrument displays, an oxygen system, pressurization system, just all the feedback stuff that a pilot requires. You can just rip all that stuff out, thereby reducing the weight, making the aircraft more aerodynamic, and therefore increasing its range and time in service. So that changes everything, right? If you can get the pilot out of the loop, it's not so much a reaction time thing as much as it is just an efficiency piece of the aircraft performance. And so Northrop Grumman's been doing this since pre-Global Hawk, right? So Global Hawk is a massive aircraft. It just is. And they've flown that thing at 70,000 feet plus, halfway around the world autonomously. So they have the technology to do this. I think this is a really weird spot right now. I think for the Air Force, don't you see this too, Dan? Like not having a pilot there feels weird, and so they still want to have a pilot in control of the autonomous aircraft. It's a weird setup because you wouldn't really need the pilot out there anymore. You wouldn't think.
Are you talking about the pilot like an accompanying jet near it, or are you talking about an actual pilot manning the controls back at the base?
Well, they may need somebody on the ground. I think that is still likely to occur. The question is, do you need somebody like in an F-35 out there? You're right. Do you need this person out there administering all this activity that your other autonomous aircraft that are flying in formation behind you? Do you need that F-35 out there? I think right now the argument is yes, but I'm not sure that's going to last very long.
Yeah, because if this was like a helicopter strike or something, for example, there's a lot more you can visually see. Like you could assess the situation. There's a human element that could be involved. Whereas at that height, you can't imagine like what decision can a human make that's not going to be based on radar or any other sort of instrumentation that it doesn't really need interpretation from the cockpit itself. Like you could interpret any of those pieces of instrumentation from thousand miles away in your base. So yeah, I guess it is unclear because it's not like he's gonna be like, come on guys, no, it's fine, or like, no, we need to pull back. You're tens and tens of thousands of feet up in the air. Yeah, the computer is gonna do pretty much most of the seeing at that point, I would assume. Right.
Is there a Top Gun situation at all? Are we quote unquote dogfighting aircraft anymore? I think the answer is no. I think the key right now is that we defend ourselves and attack from miles and miles away, which you can argue about the ethics of all that, but that's what's happening right now. So you're not having those quote unquote engagements where you're shooting machine guns at one another. That doesn't happen. Maybe air to ground that'll occur, but air to air really hasn't happened in a long time. So how many more pilots are we going to need in flying F-35 is a really good question, because autonomy is happening so fast in the air and on the ground in automobiles that you kind of wonder how much longer it's going to be. And even little tiny eVTOL companies, they're not Lockheeds, right? They're not Boeings. These small eVTOL companies have been flying these electric aircraft autonomously for years at this point, relatively safely. So it just makes you wonder, how long the pilot's going to be in this thing.
Yeah, and of course we've talked about DARPA and their work, and they've had these AI dogfight simulations where they've done well when dogfighting against a real pilot in simulators. but you're right. It seems like that day is pretty far gone. So we'll have to keep an eye on this and see how it tends to evolve. So another interesting piece of engineering is the Boeing 737 MAX 10, their wheel system. So the MAX 10 is 1.6 meters longer than the MAX 9, and apparently this little boost in fuselage length is important because now it's going to change the geometry of when the plane comes down to land, and Boeing was worried about potentially smacking the tail on the runway. So the landing gear has a really interesting mechanism where it'll actually extend to make the plane effectively stand taller to give it a little extra clearance. Alan, it seems like there's a lot of, like you said, there's a lot of engineering that even goes into the bathroom door latch. What are some of the features in this incredibly important mechanism that helps these extend out while being just as durable? Obviously, I think the landing gear is incredible that you think of this huge, heavy plane with such forces that these wheels and these little extensions can handle all that and never snap off, because they can never snap off even one time, and they don't. So take us through some of the engineering here.
Well, it's interesting because the MAX 10 has gotten so long that on takeoff on some of those longer airplanes, like the 757, some of the stretch DC-9s, MD-80s are so long on takeoff, when they pull back on the stick, that actually the tail can strike the runway. And you don't want to do that. In fact, some airplanes have like skid plates back there, and they have these tail strike sensors. It looks like a little whisker off the back end. It's like basically a switch that says, "Hey, you've hit the asphalt on the runway. Don't do that." And we need to inspect the aircraft, because you can bend a fuselage. You hit the runway hard enough with the tail. So what Boeing has done is that they've essentially extended the length of the landing gear by about 10 inches, but it expands and grows. I need to look at the mechanism a little bit more. It seemed like on takeoff, as the aircraft lifted off, this extension would kind of pop out and help prevent the tail from striking the runway. But the problem is obviously when you extend the landing gear, you got to pull the landing gear up into the fuselage somehow, and they wanted to keep the same volume that the previous 737s in the same landing gear area, and not have to change wing spars and all the structure, so that the mechanism actually collapses, the 9 or 10 inches collapses back, so the landing gear can still fit in the same hole in the wing, so to speak. That makes a lot of sense. Now, it's funny that, there's, when you think about the MAX 10 and some of these longer 737s, you don't think about stuff like that, all the little engineering changes. And I've seen some of the other MAX 10 changes and some of the MAX changes, and you wouldn't think that Boeing would hit some of these areas. Mostly, it looks like some of them for weight savings and maybe some manufacturing savings. Like, they retouched a lot of the airplane that, as a consumer, still looks like a 737, still seems to fly like a 737. But there is a lot of engineering that goes into these model improvements, I'll say, and that you just don't get to see. So I think it is interesting that Boeing actually created a little video for this, and that's helpful, right? I think as one of the things that Boeing's going to get killed on here recently is saying, well, the engineers aren't doing their job properly. Well, they need to make some puff pieces that say, hey, yeah, we're doing some cool stuff and we are working really hard at it. And it helps. I think that kind of public relations message helps them, because they could use all the help they could get right now. Don't you think so?
Yeah, I mean, yeah, if you're only taking flack and you're never getting any pats on the back, your job becomes a grind for sure. And they do some pretty amazing work. And yeah, like I said, there's so many things on an airplane that we all take for granted. And the landing gear is really like these tiny little wheels hold up this entire gigantic plane landing at hundreds of miles per hour. Well, I guess they're probably in the single, like 150. What's touchdown? Yeah, speed 100-ish miles per hour.
Run 100-ish miles an hour. Yeah.
Yeah, I mean, it's like such crazy force, and this little mechanism keeps the whole thing from going down. So, yeah, hats off to the Boeing engineers. Pretty neat. And definitely check out the YouTube video. We'll link to it in the description below. So last on the docket today is Wright, which is a startup, WRIGHT. They say they have a 2 megawatt electric engine that they're hoping can really change and be a big part of the the switch to electric power in aircraft. Now they're definitely going to start smaller. They've said they're not trying to, immediately power 737s, and even that's a small commercial airliner. But this is a 2 megawatt motor that they say produces about 2,700 horsepower equivalent, and it's the most powerful motor designed by a factor of 2. Of course, it's designed; it's not out there yet. And they also say it's going to be very, very light. So it's in lab testing, so it does exist, and they're just working on testing. Alan, how does this design strike you, and where do we feel like the future of electric aviation stands here?
Well, the interesting thing about this Wright design and some other electric motor designs that are more recent is that they're going roughly down the same pathway, which are in a motor sense, they're permanent magnet motors, and they're trying to get the electronics to drive them as hard as they can. Now, there's some trade-offs here that have to be made in terms of the operating voltage you want to run the system at and how you can control that. But the key is here, you're dumping massive amounts of energy in a very small space. Like these motors, if 2,300 horsepower is what you said, 2,700 horsepower. Now think of what that would be in terms of an internal combustion engine. That's a big engine, right? That's like something used on like 2 race cars jammed together. It would be that kind of horsepower, but yet it's probably the size. It's less than the size of one racing engine, right? It's roughly that size. So the energy density is really high, and that means there's a lot of heat that you have to bleed off of these engines. So the issue is not so much that can you generate that kind of thrust and horsepower. The question is, can you cool it fast enough that the thing doesn't melt down? That's a bigger problem right now. And there's a lot of work on the thermodynamics of these motors, making sure they have extreme amount of airflow through them, making sure that they're monitoring the temperature of the motors so that they don't basically cook themselves, because you can't do that on some of these high power electric motors. You can definitely do that. So if you look at the Wright design, it looks like a big thermodynamics problem. They have a lot of metal surfaces, a lot of cooling holes. They must be forcing air into the motor. They may have motors that actually cool the bigger motor just to try to drive air through it. Because what do you do on the ground? And I think this is the bigger issue with these. What do you do on the ground when you're taxiing around and you don't have a lot of airflow through the motor? Like you're in flight. Can you cool it enough? What happens on takeoff? Do you over temp as just rolling down the runway and you're at max thrust, but you don't have max airflow? Can you tolerate that kind of stuff? So the kicker here is we're going to see a lot of these high powered permanent magnet motors start popping out, but the industry is going to develop around it are the thermodynamics engineers that are going to be solving a lot of these airflow cooling problems. Liquid cooling will be in play in a lot of these motors, and airflow will be in play. So it's a lot of engineering challenges ahead.
Well, 2 things. Number one, that makes me think of this time when I was coming back mostly across the country with a car that's radiator I didn't know what was wrong with it, but it was not working. So if I was in a residential area going slow or stopped, I just watched my temperature go up to the red line. I was like, so I had to stay at speed. So when I was on the highway, it could cool itself. But when I slowed down or I stopped or I was at a red light, I was just like, come on, change, gotta get green so I can cool this car off again. And then eventually got it replaced. But yeah, so I feel your pain on the runway there. But number 2, I mean, the fact that they won't have to carry so much fuel on board, that weight savings, can they use that for like a really serious, huge fish tank, like water cooling system? I mean, you see some computers that have, and lots of servers have not water cooled, but liquid cooling. I mean, is that something that can support this, where it's like, hey, we saved X amount of pounds on fuel weight, so we have a really insane cooling system? I mean, is that trade-off going to happen, or is that maybe a little too ambitious?
Yeah, no, there's a lot of trade-offs going on right now, particularly the larger electric aircraft designs, which is, how much horsepower can I generate? How much cooling system can I tolerate in terms of the weight, right? And it's going to be a liquid cooling system, a lot of them. And then how much energy can my batteries maximally deliver for this motor? Can I even drive it hard enough with the batteries that I have? Can I deliver enough current? And do I need to be operating at a higher voltage to reduce the losses in cables? I mean, there's a lot of weird engineering analysis that are going on that haven't been done before, because you're right, Dan. I mean, the thing about batteries is you have this sort of fixed pack and the weight never changes, versus fuel. As you burn it off, the aircraft gets lighter, and that's advantageous. So you actually get more efficient as you burn off fuel. So you kind of, after like half a flight, or you cooked off half the battery's energy, you got this dead weight, right? And you have to carry that dead weight around. So the dynamics change a lot versus a traditional internal combustion engine or jet airframe. What do you do with this weight, and how do you manage this weight? And are the batteries carrying enough energy density? The answer is always no, right? You always like to double the energy density if you could, because you're going to have a fixed amount of weight you can tolerate. I think that's what's happening on the batteries, and then everything else is sort of designed downhill from that. But it's going to lead to a lot of different aircraft designs, and I think, like I'm saying, the thermodynamic designs are going to get really intricate. They're going to be little tiny design details that are going to make these electric motors work or not work, and we're going to see a lot of development in those areas. So making electricity go down wires and turn motors, it's relatively simple. Cooling all that is complicated.
Well, on that note, we're going to end today's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe, whether you listen on iTunes, Spotify, Stitcher, or if you watch us on YouTube. And if you have the moment, please leave us a review of the show. We'd greatly appreciate it. As you know, reviews always help drive new listeners and convince them to take a chance on our podcast. Thanks again, and we'll see you next week on Struck. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.